Okay, in this particular section, I'm going to show you some special formulas that we can use here for factoring. So we're going to start with a formula you're probably familiar with. If you go back and think about multiplying, we showed you that if you multiplied a plus b times a minus b, you would just get a squared minus b squared. So if you want to factor this, if you see a term that is just the difference of two perfect squares, then you should know that you can factor it into the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. Now that's a mouthful, but it's really not that difficult. So here are some examples if you want to look at some. X squared minus 36, that would be the difference of two perfect squares, because x squared is a perfect square, 36 is a perfect square. 4y squared minus 9z squared is the difference of two perfect squares, because 4y squared is just 2y quantity squared, and 9z squared is 3z quantity squared. And then here 100x to the fourth, that's just 10x squared squared. And then 49y to the 6th, that would just be 7y cubed quantity squared. And then here you have 81m to the 4th minus 16m to the 4th, so that would just be 9m squared squared, and this would be 4n squared squared, and so forth. And even this one, x plus 3 quantity squared minus y plus 1 quantity squared, well, that would just be the x plus 3 squared minus the y plus 1 squared. That one's a little bit odd, and we'll look at that in a minute. So one way to determine how to factor these difference of squares is to think about what are they, what values are squared. So on the x squared, it's pretty obvious, that's just x squared. But on 36, that's actually 6 squared. So that's the clue as to what this is going to factor into. This is going to factor into the square root of x squared, which is x, plus the square root of 36, which is 6, times the square root of x squared, which is x, minus the square root of 36, which is 6. So again, I find it helpful. You may not have to write this out, but if you can mentally think of it, what is squared to give 36, then that'll help you get the answer. So here I have 4y squared, which is a perfect square, minus 9z squared, which is a perfect square. Now I know 4y squared is 2y quantity squared, and I know 9z squared is 3z quantity squared. So that must factor into 2y plus 3z times 2y minus 3z. You see? So again, we're just using this formula up here. All right, let's take a look at 100x to the 4th minus 49y to the 6th. Well, 100x to the 4th is actually 10x squared quantity squared, and 49y to the 6th is 7y cubed quantity squared. So this would actually factor into 10x squared plus 7y cubed times 10x squared minus 7y cubed. I wanted to be sure and give you one that would actually factor twice. So let's take a look at this one. 81m to the 4th minus 16n to the 4th. If you write that as something squared, 81m to the 4th is 9m squared quantity squared, and 16n to the 4th is 4n squared quantity squared. So using the difference of squares formula for factoring, that will factor into 9m squared plus 4n squared times 9m squared minus 4n squared. Okay, but we're not done. Okay, if you'll remember here, I just showed you that anytime you have difference of squares, notice that this is difference of squares. So 9m squared is a perfect square, and 4n squared is a perfect square. Now I didn't write these out as 3m quantity squared, and this is 2n quantity squared, but that's what they are. So this would factor again. So we can factor this again. Now sum of perfect squares don't factor, so I'll just have to bring down the 9m squared plus 4n squared. So this one will not factor. But the 9m squared minus 4n squared, that factors into the square root of 9m squared, which is 3m, plus the square root of 4n squared, which is 2n, times the square root of 9m squared, which is 3m, minus the square root of 4n squared, which is 2n. So that factors into 3 factors: 9m squared plus 4n squared, 3m plus 2n, and 3m minus 2n. And again, don't forget this warning, sum of squares. We have no formula for factoring the sum of squares. Okay, if you look down here, I actually say it again, like x squared plus 36, 4y squared plus 9z squared, 100x to the fourth plus 49y to the sixth. We don't have any formulas to factor those, because those are sum of perfect squares. Okay, let's do this last one here. Here we have x plus 3 quantity squared minus y plus 1 quantity squared. Well, so you take the square root of the first term, which would be x plus 3, plus the square root of the second term, which would be y plus 1, and then times the square root of the first term minus the square root of the second term. So you get x plus 3 times y minus 1. Now all I did here was just simplify this. This is going to be x plus y, and then 3 plus 1 is 4. So that first factor becomes x plus y plus 4. And then this one becomes x minus y, and then 3 minus 1 is 2. So this becomes x minus y plus 2. So in this one, and in this one, the squares up here were actually binomials that were squared. Some other formulas are formulas for perfect square trinomials. Now, perfect square trinomials, in order to recognize those, you have to notice that the first term and the last term is squared. And then the middle term has to be twice the product of these square roots. Okay? And then if you recognize a trinomial in that form, then if the middle sign is plus, then it factors into a plus b times a plus b, or a plus b quantity squared. If the middle sign is minus, then it factors into a minus b times a minus b, or a minus b quantity squared. So, for instance, let me show you some perfect squares here. Okay, we'll factor these later, but right now I just want to show you how I can recognize that these trinomials are perfect squares. Notice here the x squared is a squared term, and the 4 is a squared term, because x squared is, x squared, and 4 is 2 squared. But notice the middle term. The middle term is double the product. Think of what's the square root of x squared? It's x. What's the square root of 4? It's 2. Multiply those together, x times 2, 2x. And if you double that, you get 4x. So as long as the middle term is twice the product of these square roots, then we know this is a perfect square trinomial. Here's another one. 4y squared is a perfect square because it can be written as 2y quantity squared. 9 is a perfect square. It can be written as 3 quantity squared. And notice that minus 12y is the same as twice 2y times 3, which is 2y is the square root of the 4y squared, and 3 is the square root of the 9. So since the middle term can be represented as twice the product of 2y and 3, then this is a perfect square trinomial. Okay, here's another one. 25m to the fourth is 5m squared quantity squared, and 16n squared is 4n quantity squared. So look at the middle term, 40m squared n. Well, if you take the square root of this, you get 5m squared. If you take the square root of this, you get 4n. Multiply those together, 5m squared times 4n is 20m squared n. And if you double that, you get the middle term, 40m squared n. So all three of these are perfect square trinomials. Now, since they're perfect square trinomials, since that's a perfect square trinomial, I know that the middle term works, then this must simply factor into the square root of this, which is x, plus the square root of the third term, which is 2, and then times x plus 2 again, or x plus 2 quantity squared. For this one here, we've established up here that this is a perfect square trinomial, so it must factor into the square root of 4y squared, which is 2y, minus the square root of 9, which is 3, and then 2y minus 3 again. And by the way, this one is minus. These binomials are differences, or minus, because the middle term is minus. See? And over here, the middle term was plus, so we used positive values, positive signs here, plus signs. Okay, now this one, again, we determined that this is a perfect square trinomial up here, and so it should factor into the square root of 25m to the fourth, which is 5m squared, plus the square root of 6n squared, which is 4n, times the same thing, 5n squared plus 4n, or 5m squared plus 4n quantity squared. Now, I'm just showing you that this and this are the same, so it really doesn't matter how you write them. They represent the same thing. Now, with practice, I can tell. So if I look at this one, I can see that the first term and the third term are perfect squares. And if you think of the square root of x squared is x, and the square root of 64 is 8, well, their product is 8x. And notice that the middle term is double, or twice 8x. So that tells me this is a perfect square trinomial. So it must factor into the square root of the first term, which is x, plus the square root of the last term, which is 4, times the same factor, x plus 4, or x plus 4 quantity squared. Here, this is a perfect square. M to the fourth is m squared squared, and 81 is 9 squared. And if you multiply m squared times 9, you get 9m squared, and then if you double it, you get 18m squared. So this must factor into the square root of the first term minus, because the middle term has a minus up here, so minus 9, and then m squared minus 9 again. But remember, you have to check and see if you can continue to factor. Notice that m squared minus 9 is difference of squares. So I can factor this m squared minus 9 into m plus 3, m minus 3, and I can factor this m squared minus 9 into m plus 3 and m minus 3. And then if I rearrange the factors a little bit, I can write that as m plus 3 quantity squared times m minus 3 quantity squared. The last example here I want to show you is just because the first term is a perfect square and the last term is a perfect square, it doesn't mean you have a perfect square trinomial. Because if you think about this, this one doesn't fit the rule. See, the square root of 4x squared is 2x. The square root of 9 is 3. 2x times 3 would be 6x, and if you double that, you don't get 20, you get 12. So this would have to be a 12x or a minus 12x for this to be a perfect square trinomial. Now, does it factor? Yeah, it will factor, but you can factor it using a grouping or trial and error method and show that it does factor, but it doesn't factor as a perfect square trinomial. Okay, so that's not all of the special formulas. I've got one more video that I'm going to give you on this section that talks about the sum or difference of two perfect cubes. So you may or may not study this in your particular algebra class, but it's here if you need it in the next video.